So in today's video, we're going to be learning about how to perform calculations involving molar concentration, which is also known as molarity. So these will be worked solutions for 4 different examples from Unit 8, worksheet number 2. So the first one is question number 2, which reads, a 45.3 gram sample of potassium nitrate is dissolved in enough water to make 225 milliliters of solution. Determine the molar concentration of the potassium nitrate solution. So the first thing that we need to do in order to work out molar concentration is to determine how many moles we have of the substance that is being dissolved, the solute. So we take our 45.3 gram mass, and using the molar mass of potassium nitrate, we determine that there is 0.448 moles. As before, with our normal practice, there are more decimal places we're not including, so we're using the 3 dots to signify that. So now we have the number of moles. We need to work out the volume of solvent, that in this case water, the solute is being dissolved in. Now this volume needs to be expressed in litres, which is our standard unit of volume. But if you notice that in the question we're given a value of 225 millilitres, so we need to convert that value to litres by dividing by 1,000. We're using a ratio of 1 litre for every 1,000 mils. So we get a volume of 0.225 litres. So now, in order to work out the molar concentration, we take the number of moles and divide by the volume in litres. So we have 0.448 moles divided by 0.225 litres, so we get a value of 1.99 moles for every 1 litre, or expressed as 1.99 moles per litre. The next one that we'll move to is question 8. So if 10 grams of silver nitrate is available, find the volume needed to prepare a 0.25 mole per litre silver nitrate solution. So just as before, what we need to work out first is how many moles of silver nitrate are we dissolving? So taking our 10 gram mass, multiplying by 1 mole for every, divided by the molar mass of silver nitrate. So we get 0.0589 moles. So we know that the relationship is concentration equals moles divided by volume. But in this question, that we're looking at finding the volume needed to prepare a given solution. We're told a number of moles, and we're told the concentration that it ends up being. So we need to rearrange our equation so that volume is the subject. So if we put in the values that we do have, we see that we're signifying the volume by x litres. If we rearrange this equation so x is the subject, we get x equals 0.0589 moles divided by 0.25 moles per litre. And this will give us our volume in litres. We now move on to question number 10. How many moles of lead 2 hydroxide, which is a solid, can be formed when 0.0225 litres of 0.135 mole per litre lead nitrate solution reacts with excess sodium hydroxide? Now, while this does involve concentrations of solutions, because we're involving a chemical reaction, we need to involve a BCA table to identify how many moles are present before and after this reaction happens, to allow us to determine the moles of our lead hydroxide precipitate. So first and foremost, we start with a balanced chemical equation. Lead nitrate plus 2 sodium hydroxides gives lead hydroxide as a solid and sodium nitrate. So with the information that we've got, we need to calculate what's in our before line of the table. So we work out the number of moles of lead nitrate by doing it concentration times its volume. So we work out we have 0.00303 moles with additional decimal places not shown. So we can put this into our equation. And so we can put that in for our lead nitrate. And assuming it all reacts, we end up with 0. We know that we have excess sodium hydroxide and 0 moles of both of our products. So we can now use the mole ratio in our equation to help us to fill in the change line for each of the other substances. So by looking at a 2-to-1 mole ratio, we see we use up twice as much sodium hydroxide, but we still have an excess in the end. So that's what we would write in our after line. And then likewise, we can look at our mole ratio and see that the ratio of lead nitrate to lead hydroxide is 1-to-1. So the number of moles of lead hydroxide will be the same number of moles as was used up from lead nitrate. And then we see it's the same 2-to-1 mole ratio with sodium nitrate. So we end up with 0.00606 moles. Okay? And so we can use this information to answer the question by saying we got 0.00303 moles of lead hydroxide formed. So now we come to our final example, where we're looking at a reaction between calcium chloride and sodium carbonate to form solid calcium carbonate and aqueous sodium chloride. We need to determine the volume of a 2.00 mole per litre calcium chloride solution that would be needed to exactly react with 0.0650 litres of 1.50 mole per litre sodium carbonate solution. So just as before, we start with a balanced chemical equation with 1 calcium chloride plus 1 sodium carbonate forming 1 calcium carbonate solid and 2 sodium chlorides. Now we need to start with the information that we know in order to calculate the moles of our known reactant, which in this case will be sodium carbonate because it's the only one that we're told 2 bits of information about. So to work out the moles of sodium carbonate, we do multiply its concentration by its volume, and so we get a particular number of moles. We put this into our before line of our chemical equation. Because it's completely reacting, we know that we end up with 0. So we're using up all the moles of sodium carbonate. We know that we will have excess calcium chloride. We'll have more than we need. What we need to determine is the change line. But we also know that we will only have 0 moles of both products. So by looking at our equation, we can see that the mole ratio with calcium chloride is 1 to 1. So therefore, the number of moles of calcium chloride that get used up is exactly the same as the sodium carbonate. And so that's important information. We can also use the ratios that we see to fill out for calcium carbonate and for sodium chloride. But so what we're being asked to find is the volume of the calcium chloride solution that we would need in order to be providing 0.0975 moles. So we look at the moles and divide it by its concentration to find the volume. So we get a volume of 0.0488 litres. So therefore, 0.0488 litres or 48.8 mils of calcium chloride solution will be required for reaction. Okay, and so that's going through those worked solutions. Thanks for watching.